Welcome mathematicians to this video. Today's video will be focusing on both transition matrices and state matrices with one particular example. Before we continue on to watch this video, I do recommend you watch the following video as a starting point of state matrices. Thank you. So our scenario is students at a school chose one elective activity in each of 4 terms for 2020. Their choices are communication, C, investigation, I, problem solving, S, and service, S. The transition matrix T shows the way in which senior students are expected to change their choice of electives activity from term to term. So here's our transition. So it shows this term, the 1, 2, 3, 4 different options available in terms of their elective activities, to the next term, 1, 2, 3, 4. So it's a massive 4x4 transition matrix. Let Sn be the state matrix for the number of senior students expected to choose each elective activity in term n. For the given matrix S1, a matrix rule can be used to predict the number of senior students in each elective activity in terms 2, 3, and 4. Is as follows. So here's our rule. Here's S1, and here's our transition matrix. So let's have a go at some questions. Question number 1. How many senior students will not change their elective activity from term 1 to term 2? So here's our starting matrix at term 1, and let's use that information and the transition matrix to answer this question. So first of all, the number of students starting in term 1 undertaking the communication elective is 300. Now, we find that 40% of the students who take communication this term will stay in communication next term. So 40% of 300, or 0.4 times 300, is 120 communication students who will not change their elective activity from term 1 to term 2. The investigation students, there's 200 of those in term 1. Now of those, 40% from this term will not change to next term. So 40%, or 0.4 of 200, is 80 students, the investigation group, that will stay in the same investigation group next term, term 2. Of the problem solving, we have 200 students, and we find that 30%, 0.3 of those doing problem solving this term will remain in problem solving next term. So 0.3 of 200 is 60 students. And finally, of those studying service electives in term 1, there's 300, we find that 20% of those will remain in the service elective in term 2. So 20% of 300, or 0.2 times 300, is 60 students. When we add them all up together, we find from term 1 to term 2, there are 320 students that do not change their elective activities. Question 2, we're asked to calculate state 2, the state matrix for term 2. So this is calculated by multiplying the transition matrix by state 1, term 1 matrix. Here's our values. We multiply them together on our calculator, and we find the values for term 2 are as shown. Question number 3. Now this is a slightly tricky question. Let's try this slowly but steady. Question 3 asks, of the senior students expected to choose investigation in term 3, what percentage chose service in term 2? So first of all, let's do a state for term 3. So here's our transition matrix. We're multiplying it by state 2 to work out what the new state 3 is. So there's our values. We'll place that down the bottom. So we now know here's our numbers for term 1, here's our numbers for term 2, and our numbers for term 3. Let's go back to our question. Of the senior students expected to choose investigation in term 3, what percentage chose service in term 2? In term 2, those who chose service, there was 200, as we can see here by our state 2 matrix. Term 2 service who transitioned into term 3 investigation is 200 from service going into investigation is 30%. So 200 times 30%, or 0.3, is 60. So of these 200, we find there are 60 students that transition from service into investigation in term 3. Now in term 3, we've got a total of 240 students undertaking the investigation elective. So of the senior students who chose investigation in term 3, what percentage chose service in term 2? Here we go. 60 of them came from service in term 2 out of a total of 240. So of the students who chose investigation in term 3, 25% of them chose service in term 2. I hope this example has been useful in terms of understanding how we can use state and transition matrices to solve everyday problems, including the tricky working backwards example. If you've enjoyed this and found it of some kind of value, please like, share, comment, and subscribe. And as always, thanks for watching.